Hello.
Hello.
It's my favorite thing that we do. Hello, Andres.
Hello.
Good morning to you, sir.
Yeah, it's still morning.
Y-
Good noon for you.
Afternoon. Good noon to me. Now, you know what? Today is almost a sad day for me because you and I always talk about how much we love that intro. It's not a particularly pleasing visual, but that song is banging, or the music, I guess. But that's going to be the last time we have that intro,
Yeah,
isn't it?
it is. It is, and I'm excited
It,
for the next one.
me
We're always
too. Me
improving,
too.
always iterating. That's kind of how we work in life and in code and in everything we do.
That's right. Yeah, that's exactly right. There's actually a lot that's changing for this show. For one, I don't know if anybody saw me post it on LinkedIn last week. Andres and I are actually making a 90s style sitcom intro for this show. Basically, everything is like formalizing for this for Null Check, which is the name of this show. And we have a theme song, an actual theme song. They're gonna have a intro video. There's a new YouTube channel for this. We're actually going to be departing from the Believe in Serverless YouTube channel to our own, and I prepped this ahead of time, and I just have to remember how to bring it up in our streaming platform. Here it is.
Oh, look at that.
That's the QR code for the new YouTube channel that's going to be hosting Andres and I going forward after today.
Yeah.
YouTube.com/at nullcheck TV. Nullcheck was taken, but nullcheck TV works.
I like TV. I don't know if you ever seen a channel called Are You Kidding TV? It just reminds me of
Oh,
that. It's a fun channel. They do challenges and weird challenges and stuff, and they give money out, kind of Mr. Beast style stuff. Uh,
he doesn't like
I like the
that.
suffix, the TV suffix. It's nice.
Yeah, yeah. Again, makes it feel more real, which is totally what we're going for now. And I don't know if anybody saw also on LinkedIn. I need to be more present on Twitter, I think. We've started we started showing clips from the show, so you don't have to be here for an hour at a time. I mean, you probably should because it's a lot of fun and you get
Yeah.
your questions answered. And on that note, hey Bavesh, but we did actually start pulling out the important things from what we're talking about and posting them on social media, and those will also be on our YouTube channel as well.
Yeah. So slim down version of all the learning sessions. I don't know what we call it, but the learning points.
I guess we could have. We probably could have ended it at learning, just for all the learning.
Yeah. Any big points made during the stream where you'll learn the most, we'll try and capture those and share them individually. But obviously, the full content, you will get the laughs and the tears and all that we go through.
Yes, and we hired a studio audience. Can I hear you, studio audience? Anyway, we're digressing at this point.
Yes,
So
let's move on.
we, Andres and I, and Nolchek are currently going through enterprise grade AI agent design principles. So many words, so many buzzwords. Hopefully, I connect with somebody on all those words. There are 6, and we'll go over those in a little bit more detail today because I actually have them printed out. But last time we met, Andres, what did we go over first time?
It was the first principle. Whew, you caught me off guard there. It's the system prompt, the importance of the system prompt.
Yeah, so last time we were talking about the system prompt and how important it is for determinism and getting a consistent output and getting the output that you want. So we're going, again, point forward. We're assuming that we're going to do that system prompt right. Pretty much
Yes.
that's our foundation for everything going forward. Today, I'm going to, on the spot again, what are we going over today, Andres?
Context. How much is too much context, right? So it's finding that fine line between throwing a ton of context, more pointed context, too little context. So being able to give it enough information for it to work correctly, not giving up a lot of what we're going to actually talk about.
Yeah. Work is such a, like, saying work correctly is an interesting term. Because I don't know. I would debate the semantics on work correctly, but I get your point because I know what we're about to talk about.
Yes.
But for everybody else, what we're talking about, and this is actually really important, we're talking about AI, autonomous AI agent design. Andres is distracted, I see.
Yes, I'm back. Autonomous AI.
Okay. Yeah, so we're talking about autonomous AI agents. So these are things that aren't responding to free text form. So what everybody knows, right? ChatGPT, Claude, all of our IDE agents that we're just saying, do this, do that, give me an answer. I've equipped you with tools. These are agents that are responding to events in a system. So not free text. Now, some of the inputs that could go to them is free text, like what we're going to be talking about today. But in general, this is going to be structured data with some unstructured inputs inside of that structured data. And so when we're talking about building context and establishing what are the messages that are going to be going into this autonomous AI agent, figuring out how much to give it is extremely important. And there's several reasons why, which we'll go over in a little bit. But we're going to start off with a behavior that I know I am guilty of, which is throwing the book at it. And one more thing before we just get into it. Just because these models have context windows that are a million tokens. I don't actually remember how many there are, but it's literally you could throw an entire book at an LLM and hit send, and it can do something. You shouldn't, because there are a lot of things that can go wrong when you give it too much information. And that's what we're going to be exploring all day today for the next 50 minutes. That's what we're going to be going over.
Woohoo.
Exciting stuff. So let's bring out the Promptatron 3000. Here we go. There it is.
Yes.
I think we said last time we were going to be iterating on this. Let me zoom in a little bit. There we go. Just one. We were going to be iterating on this, and it was going to continue to get better every week as we show these new principles. We did. And probably the most important one, Andres, you were responsible for this week.
Yes. So this week I worked on giving our agent a personality and a name. So you'll see that basic Promptatron robot will now have a new face once Alan clicks that reveal agent.
That's right. This agent is the one that you see in the rom-coms where she's wearing her hair up in a bun and she's wearing her glasses. She's carrying the books around town. Nobody gives her a second glance. But we're about to do the blow up on this, on our AI agent.
I'm sad there's not like a drum. We don't have a drum roll sound, Alan. We did not. We missed that in our preparation, but
sound bites we could play. So here we go. And 3, 2, 1. Well, there
Welcome.
he is.
Yay.
Welcome, Chad.
There's Chad. Chad, our agent. Oh, man. Spent way too much time getting that hair. So he has frosted tips, a polo shirt, and he's a typical, what is early 2000s Chad.
We have fun.
I was
here,
thinking
everybody.
of giving it like the double polo. You know how that was a thing. That would have been too hard in an SVG.
Yeah, you did a good job. Now, just a reminder: Chad doesn't actually do anything. He's just here as our playful companion. We'll probably, I think, next time allow you to move him around so he's not over not over the content. This is a result of us not testing at the resolution that we stream on.
Yeah. Whoops.
But
We
yeah,
don't have a QA,
yeah,
so if anybody wants to volunteer, just send
it
us
is
a
what it is.
message.
Yes. Anyway, so this is Promptatron, completely open source project. And this really is designed to help you build better AI agents. So it allows you to run different scenarios. You can configure the system prompts, the user prompts individually. You can give it tools, give the agent tools to execute. You can choose to follow the tools or just see which ones it wants to use. And then we have other cool things baked in here, like determinism that we looked at last time. I fixed all the bugs from the last stream. And then you can see history of what did you do, and you can compare results as well. I did add a settings dialog now because it's getting to the point where there's enough in here where there's settings. But what I actually wanted to show is in this about dialog, and this is what we are going to be going through over the next several weeks. The 6 principles of AI agent building. And just to go over them quickly, 1, system prompts are the key to success. And we figured that out last time. Yes, they are.
Yep.
We saw a big uptick in determinism when you built it out. There is a framework that I learned about recently called the RISEN framework, which is an acronym, which described basically exactly what we did. Define the role, define the input that's coming in, what steps you need the agent to take, what you expect in the output, and then how can you refine the output with all of your details. Today, we're going to be talking about minimizing the data context, and specifically, don't pass in a wall of text. And really, our goal for today is to figure out what's the sweet spot, is what's too much, what's too little, and when can we rely on an LLM to use tools to do data loading instead. And then, this has already been on the screen. I'm not going to read all these because I don't want to give away a whole lot of what we're going to be doing between now and reInvent. But these are the things that we are going to be going over week over week. Okay.
Sweet.
Very cool. Very cool.
Thanks for adding it there. I was still referencing our picture and then finding it and losing it. So having it in the app is way easier.
Yeah, same. Okay. So today, our use case is a little bit different. Last time we were talking about fraud detection. Great enterprise use case. This week, our use case is changing to another solid enterprise use case. I actually am a big fan. We are going to be talking about shipping logistics. Meaning, what do you do when something goes wrong in last mile delivery? If anybody doesn't know, last mile is actually an industry term in that space. It's when your stuff's on the truck and it's going from the distribution center to your house. That's last mile. Everything else, I don't actually know what those industry terms are called, but this is what happens when it can't get to you. So we have ourselves a shipping logistics scenario. Andres, has anything ever failed to get to your house before?
Oh, many times. And then you have to ask for. I actually had a recent one where I didn't get what I needed, and then I requested right through the big platform. And then they sent another one, but they wanted me to return something, but I didn't have anything because it didn't arrive, right? So I got into this weird situation where I had to go through support and all that fun stuff. But yeah, many, many times where things either get lost or you get sold something that doesn't exist anymore, or whole family orders a lot of Amazon packages.
Don't we all? So that sounds like a bad user experience, is it not?
Yeah, for sure.
Experience, which is ripe for autonomous AI agents help. I think, regardless, if your package isn't coming to you, that's going to be a bad experience. So really what we're trying to do here is make it the least bad.
Yep.
Sound good?
Because it's still good. Yeah, it's still going to be bad, but least bad.
Yeah, but like in theory, the shipping company should have told you that X, Y, or Z before you had to tell them. They needed to be proactive rather than being reactive, because now the onus is on you. and it's making the matter worse because I just want it done for me.
Yep.
We're going to do that. We're going to figure out, can we get an AI agent to do that for us? So here's an enhancement to Promptitron. See this little green guy? This is a system prompt that is associated with our shipping logistics scenario that we're running.
Ooh.
So I'm going to click on this, and we have, yay, an actual good system prompt that strongly defines the output and behavior that we want from this guy. So I don't like reading big walls of text. So we're just going to go over very high level what is it going to do. So we have, here's your priority. Always do safety, always do compliance, then do SLAs, and then how much is it going to cost the company? These are your priority things. This is what you're trying to save when we're giving this instruction to the AI agent. It has decision trees in here for how to navigate behavior and make decisions. It defines the tools. Well, no, it doesn't. It tells you that it tells it to use the tools necessary to complete the job, and then it has the output format in here, and then it has some of this information, because really what we're trying to do is we're trying to get the agent to act. Really, we're not trying to get it to respond to us, because this autonomous AI agent in a production scenario is not talking to a person back and forth. It's reacting to an event, which is the delivery driver putting in a comment that says, hey, I couldn't do this, here's why. So now we're going to figure out what to do. Okay, pretty good. User prompts. I don't have one in here because really the whole point of today is to go through user prompts. I do, however, have one prepared, and I'm going to paste it in here.
Whoa, where'd it go?
I don't know. I feel like I broke the form. Oh, did I go over like some limit?
Yeah, I mean that isn't a prompt, man. That looks like more like a novel.
It is definitely a novel. Okay, well, that's unfortunate. I didn't know we had that baked in here. We got to get rid of 3,000 characters. I'll just go ahead and do the spoiler alert. That wasn't going to work. This was too much information. But you know what we can do? We can actually go through it, because, like I said earlier, I'm guilty of doing stuff like this. This is a very, I don't know. It's a behavior that feels intuitive to me. I want an AI agent to solve a problem, so I'm going to give it all the information. I'm going to give it a wall of text, everything that I can. And that it really doesn't work well. There's a couple of reasons why big walls of text doesn't work like this. Anders, do you know what any of these could possibly be? Why a 13,000 character user prompt doesn't really work?
Well, it's just going to miss the point of what you're trying to do, right? So it's just so much stuff that it needs to ingest, right? So things get very noisy for the agent to then be able to actually act on what you want, right? So it's going to get, say, confused. So it's just too much, and it may just, again, the instruction might get lost within all this. It might just look at the first part and then see a bunch of information that you're giving it and miss the rules that are explained later on.
That's right. That's exactly right. And in this scenario, LLMs feel surprisingly human. What you're describing is instruction dilution. And we've all been through this scenario where we're having a conversation and it starts off very meaningful. You and I do this all the time. We start talking about the enhancements we're going to do to this for next week. And then we start talking about everything under the sun. It could be something that our kids did. It could be something that is a tangent. Oh, I didn't know this about this LLM. Did you see that this one was released today? And we go on and we go on and we talk about all these things that are tangentially related that is not really relevant to the task at hand. So by the time that you and I are done talking, I don't have any idea what I was supposed to do. And
Yep.
that's what happens with LLMs. That's instruction dilution. You just give it too much stuff. It reads everything. It gets overwhelmed. And it's like, well, that's really cool information. What now?
Yeah, and that's a very common scenario. I mean, and we've seen it when we've tried the different coding AI agents, and we just do, hey, this is kind of our scenario. These are the requirements. And then it's like a wall of text of 18, 20, 25 requirements. And that never ended well, rather than going kind of what we've been doing now with Kiro, which is, hey, let's go through this specific scenario, define this specific requirement, and more punctual, to really get to the point of what you want to do, rather than it getting confused and sidetracked with some other stuff.
That's right. So let's take a look at what's too much for something like this. Because again, this is something that I would do as a developer. I think, well, let me give it everything. So information that you could possibly give a shipping logistics agent. So, we prefix the prompt. Shipping exception alert. We need immediate action. So we're instilling urgency in something that doesn't feel emotions. This might not be the best way to start, but we give it important information. Here's the incident ID. It's a high priority. Give it this date, and then where it came from, where the event came from. And then we're going to give it the directives, which we've already defined in the system prompt. So we've doubled up here. And this is one of the things where developers are like, I'm just going to be safe and add it to the user prompt. Don't. It's already there. Customer profile. So it's loading everything about that customer that it was supposed to go to, because why not? Right? Maybe the LLM will find something in here that will help it decide what action to take at the end. So here's all the recent activity. Here's your preferences. Here's the information about the specific order. Here's the billing address. So it's information that seems relevant. Like as a developer, all these things that we're going over, it makes sense. It's like, these are the types of things that I would look at if I was troubleshooting something, if I was trying to debug manually. It's carrier and tracking information. It's all these things. Here's the SLA. The SLA, again, is something that is static information. SLAs don't really change. And when they do, they're still coming from a static thing. It's not an SLA for a particular package, right? You might have different tiers based on a customer level, but even if you're doing that, you can still load the SLA for that specific customer if they're a VIP or something, or a free tier. More information about the warehouse. Here are the related orders. Here's how we normally do. So it's trying to give additional context for everything about this package. Here's the information about expedited shipping. So this is information for actions that it can take. So if it decides that you need to do expedited shipping to resolve this issue with this package, here's what you do. Here are your different options. Again, static. Maybe these can be calculated, but information that doesn't necessarily need to be provided in this initial prompt. The weather. Why played a factor? I don't actually know. In this case, we're trying to figure out an outcome, and the weather probably is not going to figure out what the outcome is. And then this is, again, trying to help you decide what action to take. Here are the financial information. So a whole bunch of different stuff that when you think about shipping logistics and figuring out, what do I do with this package? How do I resolve the actions here? It's all stuff that makes sense. It's all related. But we run into that prompt dilution that we talked about. And our tool is not going to do this. We need to take a note down for a bug to fix that one, to maximize this. So we're not going to run it, unfortunately. Actually, you know what? Go ahead. Let me take out.
I mean, it's local, Alan, so you can probably look for that limit somewhere.
Nah. Let's see. I'm almost there. I just need to do 800 more characters. Okay.
There you are. Woo!
So now we're just under that 10,000 limit. And one of the things that we haven't talked about yet is cost. That's obviously going to be an expensive call, but we're willing to do that for the stream. But in a production scenario where this might be happening all the time, that is actually a very expensive call to be repeating thousands of times a day. Hopefully you don't have thousands of packages that aren't being delivered every day, but
but if you're already losing money because you have to resend those, then you're spending more money because you're always spending on more tokens that you don't really need to be spending on every single agent action or agent request.
That's right. Okay, so new feature alert. Last time when we met, the Prototron 3000 could only detect tools. Now it can actually execute tools for you. So if an AI agent says, hey, I want to use these, you could say, okay, go ahead and use them. Before we were just tracking, so we could figure out outcomes and evaluate determinism. Now we're actually going to use them, and this puts us into the agent loop, which we'll talk about at a future date, where it's just going to iterate. So it's going to figure out what it needs to do. It's going to act. It's going to get the results from its action, and then figure out, does it need to continue or can it summarize from there? So we have guards in here to make sure that it doesn't run away with our maximum number of iterations. So we're going to execute tools, and we're not going to evaluate determinism, and we're going to go. We're going to stream. So from here, Andre, this is also a really cool thing that you made this week. I really like watching this work. Yes. So here's the system prompt, just as a reminder of what this does. Here's our user prompt, which is way too much information, 10,000 characters. just keep scrolling and scrolling. And then down here, it says, in summary, I have expedited this order for overnight delivery to ensure perishable goods maintain their cold chain integrity. Which is actually the right answer. I actually didn't finish going over this use case enough. We'll look at it here in a minute, a little bit more about the use case. But it was supposed to expedite this order. So this one was a failed delivery. It had something hot in it, and it was a VIP customer, so it's going to expedite. So it's coming back to the distribution center. Then they're going to send it back out as quickly as they can. That's what we're doing here. But here's the cool thing. Andres, you made this workflow timeline to show us the agent loop. And it's really cool. So iteration 1, it figured out what it needed to do. Here was its thoughts. It didn't actually put any results out. It didn't say any text, but it said, hey, I need to use a tool. And then it called get package contents. So apparently, this is not a very smart model because we provided all the contents. We provided everything.
That's true.
That it needed. In a smarter model, in a model that has a good ability to reason. Now, I'm using Haiku today because my throughput limits in Bedrock are very low for everything that's not Haiku. I tried to get it raised, but I couldn't get it raised. So we're dealing with a less than capable model today. But the main point here is that it was trying to get the package contents. It's loading the information. Is it fresh? And yes, and then iteration 2, it was getting the carrier status. So where is it now? And then down here, it was getting the quote to expedite the data. So it's figuring out, how much is that going to cost me? Iteration 4, one more tool. This is the action that we were looking for. Remember, we're trying to get deterministic actions, outcomes. And this is one of 4 possible outcomes that we enabled this agent to do via tools. So this one is expedite shipment. So we can see its information in here. We're going to overnight it because it has perishable goods and the SLA was at risk. So if it didn't hit that SLA, the item's contents were going to get ruined. Bad for everything. And then it was good. And then the LLM said, yeah, we're all set. Yeah, there we go. In summary, I have done this, which we already read. Yeah.
Good job, Chad. Look at that.
Yeah, right? That's pretty good. In theory, what we provided to it in that user prompt with a more capable model. Let's say we were using the brand new Sonnet 4.5. It wouldn't have had to do any of those besides expedite shipping because we provided it all that information already.
True.
I can try changing the model. Let's do this. Let's not change anything else except for the model. Let's use Nova Pro. This is actually a pretty good model, and I'm pretty sure I have better throughput limits on this one. So not changing anything else.
I think if you press enter, it might execute.
I don't want to, I'm not going to risk that. Okay.
So hopefully we see less iterations. Hopefully we see less iterations. Yeah, we got 2 iterations on this one.
Yeah, so in theory, I didn't see, but in theory, what we were supposed to have seen was only expedite, right? Because that's the right answer. That's the answer we were looking for. We wanted it to call to expedite and then be done.
Scroll to the top and just press markdown. And I don't know why it auto formats the SQL. But yeah, that way you get the response in markdown. So that's still the user prompt. And there it is.
Okay. So it said, oh, look, it even wrote a letter. I didn't tell it to write a letter. But, you know, when you're testing, when you're doing the dev testing, this is wasted tokens because we're not going to use that letter. That is something that it did on its own for whatever reason it thought it was a good idea to do. But if we follow the workflow timeline here, this is what we expected to see. Iteration 1 is expedite shipment. So we provided it with enough information from the get-go to make a conclusive decision to expedite the shipment. It did that, and then it said, boom, done.
I'm done.
Boom, roasted, if you've seen that episode of The Office. Which is great, which is really good. I'm actually impressed that it did that. So it's, yeah, there we go. Here's the information that it pulled out. Perishable goods at risk, VIP customer, SLA at risk. Okay, that worked.
That was pretty good.
That worked. Yeah. It shouldn't have, which kind of make me mad because don't do this. Because don't do that. And I don't have the updated token consumption in here yet. We'll have this next time. But we just spent a lot of money on that.
But that's
a lot of money at scale.
That's the point to be made here, right? Yeah, it reached the conclusion, but do you really need 10,000 characters to be able to reach to this conclusion? So as we move forward, we're going to slim this down because yeah, this worked, but this might have not worked in a different scenario or a different. Maybe if you just rerun it, it might not work the same way, right? Going back to the non-deterministic nature of agents and LLMs.
Yeah. I mean, in theory, it should be because it's a pretty solid system prompt for what we told it to do.
Yeah, that's true.
The non-deterministic side, maybe it won't write a letter next time. I really don't know why it did that. And I think I'm going to update the system prompt to tell it not to do that anymore. It actually just blatantly disregarded that last instruction. Yeah, I guess I didn't give it that last instruction. Oh, no, that's the user prompt. The system prompt.
We don't have scrollable there? Okay,
no.
Take a note of all our bugs.
Yeah, we can at least see it here. Inside of the system prompt, really, I just told it, explain your final decision and reasoning as part of the actions that it's supposed to take. And it decided to write a letter. It did this. It did explain your final decision and reasoning. And then it also said, yeah, let's notify the person, which is not the right thing to do. Okay. So let's do a smaller user prompt. Clearing this.
What did you remove?
Here we go. This one, a lot. If we're going to go through it. We're going to go through it.
Okay.
This one, is 4,300 characters versus the 10,000 that we just had. So this one, let's take a look at what's in here. So we still have this is starting to get tighter up here at the top. Before it was like shipping exception. It was giving information that really isn't relevant. Now we're starting to consolidate some of this information in here. We're still giving it the operational directives, which is duplicated from the system prompt. So write information for, excuse me, for removal. We're giving it customer information. We're giving it order details. We're saying what's in the package. And this is something that we didn't talk about before. It's Wagyu beef steaks.
Yeah,
I
was going to say, you're making me hungry.
Yeah, 3.22 steaks at 3.2 pounds. This is a big steak.
Yeah,
and valued at a pretty decent amount. So you definitely don't want this to stay outside at the person's door. Again, more carrier information about the SLA. We're giving it information that's static. So this is information that is very easily look upable, or you can put it in a RAG pipeline, which is not this episode. We can talk about that in a later date. But that's information that can definitely be vectorized. And then we have, again, information about decision making. Here's what you can do for expediting. Here's the cost of missing the SLA versus the cost of expediting, so on and so forth. And then down here at the bottom, it's one more reminder. And then the definitive action we want the thing to take. We need to pause again before we run this, because I want to talk more about some of the things that can go wrong with large user prompts. And one of the things that is interesting, it's a very interesting thing, and it's again a very human behavior, is something called recency bias. Do you know about this one?
Yes.
Do you know about the recency bias?
Yes, and the recency bias, and it's something that's happened to me a lot with coding agents. But this is where the agent gets lost around all the conversation that's happened, right? So that's if it's a long conversation, a long session, right? So the agent's keeping all that information in its session. That's why at some point you see summarizing history. And why things might get lost is because it's only looking, or it's not only looking, but it's more biased to look at actions that are asked that are more recent, right? So I've been locked sometimes in a loop where I'm working with an agent to fix a bug, or not fix a bug, but optimize a piece of code. And then it's a long, very, very, very long session, and it knows it still needs to optimize the code, but as it's failing and failing and failing, it somehow ends up with the same solution that we were trying to fix. So it kind of forgot what we were originally intending to do because it lost all that because it's looking at the more recent request.
I have run into this with ChatGPT, where I will give it an instruction. Let's say I'm debugging something that I wrote, and I start off in the chat window with, I need you to do a surgical edit on this code. Only change the line that's wrong in the code. And then I give it the error that I'm seeing, and then I paste it the entire controller and hit go. And because the thing that's last in that massive prompt, that probably 10,000 character prompt that I gave it, it has recent context of the code that I wrote, and then it just starts refactoring the whole thing because it's lost some of that instruction from the very beginning of the prompt. So I overwhelmed it with information. It has recency bias to do what it wants at the end, and then it does kind of its own thing because it doesn't think that it received instruction. All that
very,
to say,
very common. Very common.
yes, it is. And that's because that's like a standard chain of thought, right? I'm going to start with my problem. Then I'm going to give you context, and then I'm done. So what we have here, what we've done in this user prompt and all of the ones that we've done, is we're ending our prompt with the important instructions. So the very last thing that it reads is execute the appropriate action for this right now.
Yeah. And I'll bring up Peter's comment.
Peter has a pretty funny.
It's not exactly the optimal way we want to operate with agents, but it's definitely a way to get past this. But you see what you're doing is you're switching the context to another agent, and now you're giving it what you want. So it has less history. So now it executes correctly. So that's kind of what's happening. Entire
message history. Yeah. Very funny. Very funny. And that's the Peter's doing there what my kid does when she gets an answer she doesn't like from my wife. Can I watch TV? No. She comes over to me. Dad, can I watch TV? Yes. Actually, the answer I always say is what did Mom say? But
that's what I did too.
But that's what Peter's doing, right? He's shopping around for answers that he wants. Okay, so we have our reduced prompt. We have our instructions at the end. We don't have things like the weather. We don't have all this other superfluous information in here, but we did give it a lot of the information needed in order to make a decision. So we're spending, approximately half the cost on this for an outcome. Let's see what it does.
Let's do it, Chad. He's thinking. Maybe meditating for him? I don't know.
Yeah, and now he got an answer that he liked. Okay, so there's our system prompt, our user prompt. We should probably make these collapsible when we're in a zoomed in view, Andres. Okay, so it's a lot more information down here in the model response. And again, this is when with autonomous agents, we can do a couple of different things. One, we could throw it away because this is just code that's going to be receiving this response. Or we can use this to put in a summary on this specific item, the basically results, and have that be our audit information, which is really the right way. It's the right thing to do.
Yep.
So let's see what it says. The expedite shipment action was successful. So it did take the action that we wanted. Let's look at its workflow. Same thing.
2 iterations.
So it figured out it was able to reason, given all the information that we gave it, what to do. And it called expedite shipment and then said was good. Now, we expected this behavior. This is what we were hoping for. And this is, again, what we expected. Consistent with the behavior last time because of that strong system prompt. Really, we have a good level of determinism here.
Yep, but at half the cost for the user prompt, right? So I'll take it.
Yeah, if you think, I don't work in shipping logistics, so I can't say how realistic this scenario is for how many times it's going to run monthly. But let's just say that it runs 100,000 times. So maybe it's FedEx. Maybe it runs 1 million times a month. Reducing that cost by 500,000 times a month is significant. 50% savings. I'll take that every day of the week.
For sure.
Okay. Now we're going to get to the point where we're going to continue reducing down this user prompt because now we actually want it to use the tools. So what we were doing here, there is a technical term. I'll just put the learning moment thing up.
Oh, there we go.
This is a learning moment, by the way, everybody. What we are doing, whether we know it or not, there is a term for putting all this information in here. We've fetched the data deterministically, however we did it, in code, and we built this prompt up and fed it to the LLM. That's called prompt stuffing. And I don't really have another way to explain it besides that. Load all the data, put it into the prompt, feed to the LLM. Prompt stuffing. Very not cost effective, not efficient, but it does get the job done, right? It does. If you're looking for a proof of concept, that does what it says or what it's supposed to do. But again, we're not here to just make something work. We're here to make things work the right way, in enterprise production way.
Yes.
So, Andres, let's reduce this user prompt down more.
How much more, Alan?
Lear.
Ooh.
No, not that much. not 0. So we're down down to 1,200 characters. Again, a significant reduction in cost when you're talking about straight token value.
Well, this is now
And
less.
what we have,
It's less than 10% than your initial prompt, which was 13,000 characters. So just putting that into perspective.
That's right. That's right. So we don't need headers. We don't need fancy headers. We now have information about, okay, it's a shipping exception. Here's the order number. Here's the customer, but not everything about that customer. Here's the relevant information. Here is the relevant information about the order details, because really what we're doing right now is we're optimizing for tool usage. We'll get to that in a second. Here's what's in the package. Here's the packaging notes. Here's the carrier status. And this is really important information here. This is really the driving information for what we do as far as the outcome goes. I think it's time for another learning moment.
Ooh, there we go.
The two prompts that we had prior to this were very, very long. It had everything under the sun stuffed into that prompt, which gets us into the problems that we already saw with instruction dilution and recency bias, potentially, based on how we structure the end of it. But the third thing that we run into with large prompts is lost in the middle effect. It's called the lost in the middle effect. And it is exactly what you would think. The information that gets in the middle, that gets put into the middle of a very large prompt, is again probably not going to get picked up on. This would be, if you're thinking about a conversation that you have with a person, you're generally going to remember maybe the beginning, definitely the end. What happened in the middle? I don't know. When I come home after hanging out with Andres at the bar, my wife says, "What did you guys talk about?" I can usually say like one or two things, which is what he said when we greeted each other and what he said, what we were talking about at the end. That 2 hours in the middle, no idea. No idea at all. And it's really the same with LLMs. It's that's called the lost in the middle effect. So important information, the takeaway from this, really important information that helps drive outcomes should be put toward the end.
Nice.
All right. So I didn't really structure this super great. I mean, this is a pretty small prompt at this point. It's only 1,200 characters. So, we're only looking at a couple hundred tokens. Very easy to ingest from an LLM. But for the other prompts that we were working on, this really should have been at the end. Okay. And then we have the information about the SLA. What is the SLA for this specific package? We're not giving details about what that SLA is because scroll. We have tools for that. This is now where we're going to talk about the tools that we're going to use. Yes. We have get carrier status, get package contents, get customer tier, get SLA, get expedite quote, expedite shipment, hold for pickup. These are the actions here, right? Expedite shipment, hold for pickup, escalate to a manager, and nothing. Do nothing. So those are the things, those are the outcomes that are possible given the information and the situation. So these are all fetches. These are all tools that are going to load data on the left. And at this point now, we've kind of taken enough information away where we expect some of those to be used. We have IDs, and now we can actually use the tools to load information necessary. All right, Andres, call it. How many tools are we going to use? What's going to be used given the information that we saw? And is it going to reach the conclusion that we are hoping it's going to, which is expedite that shipment?
So first, I do think it'll reach the conclusion. And I think it'll do two queries to get the carrier information or the carrier status, but maybe not the package
so
contents.
Where's the package?
Yeah, package contents it does have there. So we'll see.
Yes, it does. See. And it does have that Margaret is a VIP customer. Okay, so let's see. I think that's a really good guess.
Might be just one.
I think that's a good guess. Okay, let's see. Let's see what it does. I don't know, right? This is the fun part. This is the fun part about doing stuff live. I have no idea what it's going to do. Even if I rehearse this whole thing ahead of time,
It could change, yeah.
it could be different. It could be different this time. Okay. It did the same. It had the outcome that we were hoping. The expedite shipment tool was successfully expedited. For this shipment, it will now be delivered via premium air with an ETA of today.
Ooh.
And then it has its explanation. So
It really only did the one.
it didn't. Yeah, it didn't. Did we provide enough information, do you think?
I mean, it knows that it's beef. It's meat.
Let's look at it again. Let's think about this as if we were an expert in this field, because that's what we told this LLM that it is, right? It's been empowered to make reasoning decisions. That's why we use LLMs, right? Because they have the ability to reason. So if we were given this information, Margaret's a VIP.
Yeah.
And she's very happy VIP. We tried to call her a couple times. She has an order with
This
raw
package.
Wagyu steaks valued at $340. And it's on dry ice.
Carrier status. That's the one I missed.
Carriers said that the box was warm and the customer wasn't home. So that's probably not a good sign because it needs to be not warm. And then the SLA here is 2 days, and it was by 8 a.m. or 8 p.m. today, 8 hours left. If we miss, it's $200. And then down here, the expedite options for overnight is 47, which would miss the SLA, or same day, $95. So it did have enough information to say, let's go ahead and do that. Now this, if we think about that, this is a really well-structured user prompt. It has all of the information in it. It has basically the minimum amount of information. Well, not really the minimum, because if you saw, I was just highlighted like 5 lines. We probably could have
you don't
cut that
need
down.
the full thing. Yeah.
Yep. Okay. And then it didn't have to call any other tools besides the action that it took. I think if we ran this one 1,000 times, we'd have a high percentage of the outcome that we wanted, like 99%, but I'm not convinced it would be 100%.
Okay.
Because it didn't load all the information. That's my guess. I don't know, and we're not going to do that because that'd be really expensive on my account in AWS. So we're not going to do that. So now I have 2 more prompts that we can go over. Actually, I have 3 more. Okay. Smaller prompt. Narrowing in. So now we have this format. This order. This is the customer. She's VIP. Doesn't say anything about that oh, it does. She's happy. It has Wagyu beef steaks in it that are perishable. This says the box was warm. The SLA is this. And we have the penalty fees. So my guess, what's your guess given this? It's a lot less information. This is basically the information that I was highlighting that last round, right? So we've pared it down to what I think is.
I think it's still going to just run the expedite action.
I do too. And this is 655 characters. Let's run this. If it gets to expedite, that's 16x reduction in the amount of tokens that we're using. What did it do? Oh, here we go.
Yep, 2 iterations.
It successfully called expedite shipment tool, and it did that. Okay. Now we're going to actually challenge this thing because I'm about ready for it to not just know what to do. Okay, here we go.
Do it.
Moral of the story of what we just did, though, you do not need to pass everything in. You can absolutely trim that down to the minimum amount possible. And I would actually be happy in a production scenario if this is what we passed in and the answer that we got out. You're going to have to use a higher level of reasoning model to do that. So your cost is going to go up from that capacity to be able to pass in fewer tokens. Definitely a balance there. Okay.
Yeah, like we saw with the other, what was it, Haiku?
Yeah.
It called some tools that it didn't need to, right? So that's your trade-off, right? A smarter model, but better execution.
That's right. Okay. Here we go. Order exception. The box was warm. Customer's not home. It's a VIP customer.
VIP.
Do stuff. Now we're leaving a lot of information out on this one. This is your Hello World style example prompt.
Yeah.
Let's see what it does. What do you think? I mean, basically it has to use all of those fetch tools
Yeah.
for
So get the
what it's going to
order,
do.
customer. Oh no. Did your token
My
expire?
guess is that I don't know. Yes.
Whew, I'm good at troubleshooting.
Let me do that real quick.
Good thing we just have a script for that.
Yeah. So what happened here? Just a quick explainer why that failed. My credentials timed out. So we have a script that runs locally. This is just running locally. We have a script that can go in and renew those. And it is doing that.
Or the keys, the access keys.
Yeah.
Cool.
Okay. Oh man, I hope this isn't doing what it did last time, where it said it was going to do it and then it didn't. What did I do before?
It still says 6 models available. I'm assuming it's not loading.
I think that's hard coded.
Do a new terminal.
Yeah. Okay. While that's loading, it would be. I don't want to jump ahead too much. We're getting pretty close to the time.
Yeah.
We had a lot of fun talking here. So yeah, go ahead. What were you going to say?
No, I mean, we can talk further about the expectation here, right? So we expected it to call the get carrier status, get the shipment or whatever's getting there, right? So making sure it's Wagyu, the customer to get the address. So I'm expecting it to load all of that, calling the tools, right? But the question here is, are tools always better than just providing it in the context, right? In some situations, you might not have it. In some situations, you might, but what is better? And I think the answer there is, well, it depends, right? Because a tool, you might be provided an ID and returns quickly, and it gives you the information you can provide the agent, right? So they're enriching the context, you might say, but it might not always need that, right? So you can save some money by not providing it and only calling when necessary. But what happens if the tool is returning a 10,000 character response? Then now you're hitting kind of our first scenario where you're just overloading the context. You might hit some of these issues we talked about with recency bias, lost in the middle, the instruction dilution. Yeah. So again, that's why it depends, right? If you're getting the information you need and not overloading, then you might be fine. So think of REST versus GraphQL, right? With GraphQL, you can request whatever you need, and you just I just need the name and the address. Just give me that, versus getting the full customer object with the history and all their orders.
Very well said. Couldn't agree more. And while you were talking, we got a response. I did run it, and we got a response. Woo-hoo. It used the expedite shipment tool. And it did overnight shipping this time. So this is not quite the outcome that we wanted. This one, it was supposed to use expedite shipment, but it was supposed to do same day. So let's look at the iteration that it took. Oh, it didn't do anything. That's not good. It was not. I don't know why it wouldn't call tools. And this is part of the. I mean, I guess this is part of the reason why you can't really trust an LLM. This is when the talk. I gave a talk last week on designing APIs, for use with humans and AI agents. And one of the main points in that talk is do more, build these tools that basically solve these workflows for you in one shot. What did that say? Can we just create a tool for the agent to evaluate how much context is too much context?
I mean, you can
Benjamin's
have like
skipping ahead.
we've talked about meta agents, right? But that would be
Yeah.
no, it wouldn't. It would be something because you are loading you're telling it how much context, right? So it's an agent for you. It's not a meta agent. But yeah, maybe this is part of the system prompt. Make sure you load the necessary information to take the appropriate action. And I don't know if we have that. I think you do.
We definitely
But
do.
this is
all right.
We went from always 1,000 characters to 100 or whatever you had, right? That's where you find the balance. How much context do you provide? Because maybe it didn't know it did have the ID, but maybe it didn't know because it was just embedded in a sentence.
Yeah, I'm not sure. I figured Nova Pro would use more. I changed it. Now we're just going off the rails. You can tell we're at the end of this stream. So it used expedite shipment and no action required. What on earth was its reasoning for this? The no action required tool has confirmed that no further action is needed for order B456. The shipment has been successfully expedited overnight. Oh, you know what? This is my fault.
Oh, we're storing history, right?
Yeah. So here, I set this reset button right there to bring it back to normal.
So just for everybody,
it did what it was supposed to do.
This solution has storage, right? So when it calls a tool, it's actually storing the status and the action for that order. So when it's looking at it and checks the expedite, or it's trying to do the expedite, it's already expedited or something like that, right? So there was actually no action. So it's actually a smart tool.
Yep. Yes. So I reset the data. It had a different response, like we would expect. It did get carrier status in the first iteration to figure out, what's the situation going on, and then it said expedite shipment. Again, it should have called get SLA because that SLA information is going to have the penalty associated with it. And that's probably something I'm going to try one more time because I know we're over time, but I'm going to edit the system prompt. This is one of the things that we're going to work around this bug. This is one of the things that you continuously hone. But what we need to do is we need to tell it that.
And this is where the
super annoying.
What?
Yeah, it's not expanding anymore. Go ahead. What were you saying?
This is if you watched our previous stream, it's the determinism factor, right? So and trying different LLMs, and maybe this would render different results, right? So you're honing in on your system prompt and finding what's missing, right? So you might think you have the perfect system prompt, but as you saw today, it's still not perfect.
And now it works. Okay, so I only added one thing, and this could be our last example for today. Inside of the system prompt, I added one line here. The get SLA tool will include the penalty cost of missing the SLA. So that line is me encouraging to the LLM, you should probably use that tool if that information is not provided. Switching over to the user prompt. I swear, man.
So you need to clear and then.
I don't know. We need to fix that bug. We're going to use the same one. Okay, so we can't see it because it didn't scroll for whatever reason. But this is the same user prompt that we used before, where it has the VIP. It says it's a 2-day SLA, so it's going to use that information to pull the SLA information, which we've coaxed it to say, you know what, this has the penalty if you miss. So one more time, just for kicks, let's see what it does.
Go, Chad, go.
Yeah, right. Okay, so the expedite shipment action was successful. The package has been expedited overnight. You know what? I'm getting frustrated. I'm glad we're done. It didn't call anything.
if,
Okay.
if you're not getting frustrated, it means you're not doing AI right. They're
Yeah.
all you're
Okay.
hitting the limits. So
I accept
that's
that. I accept that premise. All right. We're done. We're done. Clearly, we did not have enough information in that user prompts toward the end. We were trying to coax it to use the tools, and we couldn't make it do that. That's something that we can encourage it to do better in the system prompt. It did it fine in
and
the bigger
by
user prompts.
by looking at the system prompt where you had tool usage, you had, and maybe it's the recency bias, but you had don't load any information you don't need, and then you had the one you added, and maybe yeah, I don't know.
Yeah, no, that's a good thought. It could be a number of things. I don't know. But it goes to show, right? The whole moral of all of it is these things are non-deterministic, and the amount of information that you pass into both the system prompt and the user prompt matter critically when it comes to getting the deterministic output. So the last several that we did, where we were giving it not enough information, it expedited the shipment, but not before the SLA that we wanted. So not the outcome we were looking for. So we didn't balance it right. We didn't encourage it to use tools enough. Shame on us for that system prompt. But I think we learned a lot today. I mean, there's a lot of information. At the very least, the takeaway is you don't need all the information you think you do.
Yeah, I think that's how I promoted this session. It's trying to find the balance between too much context and not enough context, right? And I think we saw both. Because we slimmed it down until we still got the same response, and then went to the whole opposite where we just couldn't get it to do what we wanted it to do. So it's striking that balance. You don't need 20,000 characters of user context. So try and find what's actually necessary, and find ways to only get that information as it's needed in some situations. Again, tools are definitely not cheaper than tokens all the time. It might be, right? So it's striking your balance. And as with any great architect would say, it depends on your use case. So it's knowing what you can do to improve it and finding that balance for your specific use case.
Perfect. Great summary. I have no more to say to that. That was awesome. So the next time we meet, normally we're on a 2-week cadence, but I think we're going to do 1 week. The next time we're going to meet is 1 week out. I will be in England talking at a conference in 2 weeks about AI. Well, how about that? So since we don't want to go a month without a show, we're going to move it up a week. Same time, same place. Nope, not the same place. Reminder, this is going to be on a different YouTube channel next week, which is, I'm going to put the QR code back up.
I was trying. I couldn't find it.
If you want to go on there, youtube.com/@nullchecktv. So we are going to be moving off of the Believe in Serverless YouTube channel onto our own starting next week.
Super excited.
Yeah.
Like
all right. So
moving
excited.
into a new
And next
house.
week we'll have our that's right. And we'll have our sweet 90s style sitcom intro as well. So it'll be, I mean, even if you don't stay for the rest of it, come for that. It's going to be, it's going to be awesome. Yes. All right. Well, thank you everybody for staying with us today, and we will see you next time.